Hi there, please introduce yourself.
Hi, I'm Jyotsna. I am the co-founder and CEO of SpaceSense. We are a space AI startup based in Paris, set out to make intelligence from satellite imagery a mainstream commodity. We help businesses and organizations integrate this technology in their applications as easy as plug and play.
What is your definition of new space?
For me, new space refers to the movement to commercialize and hence democratize space technologies. This is driven mainly by the fact that it is no more an industry controlled by the states for the benefit of the states. So with new technologies, new business models, and applications, the private actors are making space more mainstream. So the pace of technological advancement and the rapid drop in cost has opened up this industry like never before. Industries that never imagined they would have anything to do with space have now realized that these technologies can in fact completely transform their businesses. I'm very confident that in a few years, space technologies would touch almost all industries like AI today. And this for me is new space.
How are machine learning and AI in general changing the way we use space data?
ML and AI have disrupted many industries. We don't see many industries which are untouched by it. One of the reasons for this is advancements in AI frameworks like PyTorch, TensorFlow, and breakthroughs in model architecture and new algorithms, and especially attributed to the fact that all of this is available open source. And to this list, I would also add big data and cloud computing. The reason why I say big data and cloud is because the performance of AI models is especially deep learning solutions improves with size of the data. And today the cost of storage has become cheaper and computation power has become more readily available and affordable, and it has become the primary drivers for improvement in AI and ML. This together has had an impact in AI in general, but more so with space data. Managing space data inherently is a big data problem. Satellites are not new, but the approach to generating insights from satellite imagery has been very manual and expert driven for decades. And because the Earth is not the same every few kilometers and every few months, the same task would have to be done from scratch every time, making it very difficult to scale or automate the solution. So with ML, the algorithms can very easily adapt to the changing conditions, the specificities of the location and time, driving automation of these pipelines to generate the same insights. So what has this done is it has enabled this technology to complete non-experts and also to what I call customization at scale. The advances in ML and space data derives quite a bit from the AI for computer vision. One inherent problem with space data is the availability of large training data, large label data sets. And any new, with new algorithmic innovations in AI for computer vision, like transfer learning, and one-shot learning, for example, have now made it possible for algorithms to learn very quickly and efficiently from very small data sets. And this has really been the game changer in AI applications with space data. Although at first, most of the focus was in automating what we always knew was possible with satellite imagery, like detecting floods, monitoring infrastructure. But with advances in deep learning, we are able to derive intelligence that we could not do before. And my favorite example is the project by World Bank called Poverty from Space. They used high resolution satellite imagery data to derive economic well-being in Sri Lanka at village level accuracy. It's incredible if you think about it, how deep learning algorithm was able to learn itself, among other different things, that higher the green cover in a city meant higher economic prosperity. And the same in a village would mean lower per capita income. I can easily see such a solution being a key technology being used for policy and decision making at national and international levels. So to conclude, advances in big data, cloud, and artificial intelligence are the reason why today we can improve accessibility to intelligence generated through satellite imagery to space data, and also in being able to build new solutions that were not possible before.
I know that among other things, SpaceSense is focusing on the interpretation of synthetic aperture radar imagery. What's so special about SAR imagery, and what are the challenges about using it?
SAR is an absolutely incredible technology. If you think about it, it's mind-boggling to think about a signal being sent from space to the Earth and received back. It brings a lot more information, much more comprehensive information about the Earth itself than what is possible with optical sensors. In fact, they were quite complementary in terms of what they bring in information. What's special really about SAR is that unlike other satellite imagery, unlike optical satellite imagery, it is not affected by clouds. It just pierces through these clouds. And the other factor is that it is very sensitive to the surface roughness or roughness of anything it is touching, and also the dielectric property of anything it is touching on the surface, which gives us a lot of information about everything you're trying to sense. So it's super interesting what you can derive from it, but the challenge here is really in having the domain knowledge to translate what you see from the satellite reflectance, so what you call the backscatter, to go from the values of those backscatter to actually the property that you want to measure. So this requires a lot of domain expertise, and there's a lot of physics involved behind it. With machine learning, one can always say that you can always find patterns, but if you don't try to understand the domain, then it will be almost like trying to find pattern in chaos, which you will still find, but it will be very misleading. And there's also a huge challenge in understanding the bias if you don't really understand the knowledge or the technology behind it. So, and we at SpaceSense, we understand this, and that is why we're trying to understand from the technology, the domain, what it is giving us, and use that efficiently in combination with machine learning to derive very interesting physical properties on the Earth. But in fact, the most interesting problem you're trying to solve is availability of optical data itself. So as we might have heard quite often, that the cloud cover is a huge problem for availability of satellite data. That's especially true for optical data. So what we are doing is we're combining optical and SAR to derive the same optical insights from optical data, but even on the days when there are clouds. So now the availability is almost 100% with it. So this is an interesting problem we're trying to solve at SpaceSense.
How do you think space data will have an impact on the global economy in the short and medium term?
So in the short and medium term, today I see satellite imagery being adopted by many industries, especially agriculture, climate change, disaster management, and many more. But when I look at it at a very global scale, because agriculture is able to benefit quite a lot from satellite data, we are able to produce more and more efficiently, which means better yield, which leads to more increased economic output at the end. And in terms of disaster management, satellite imagery can substantially reduce the economic and social costs of disasters. So because with satellite imagery, and especially in combination with machine learning and AI, we can predict certain disasters, which will help us manage our disaster response, and in fact, even prevent certain disasters, especially preventable disasters like fire hazards happening or forest fires happening. So this leads to a huge economic and social savings and costs. And also in our response to these disasters, because with satellite imagery, we can know exactly how much damage has happened and where exactly this damage has happened, it can help us optimize our response after the disaster, and not only save costs, but reach the areas which are most in need. So, but also in terms of little long term, if I think about it, the same technologies can help us efficiently plan our cities and countries. This is especially important for developing countries that have so far not had the technology or the resources to understand where their people are, where the needs are, where their resources are. So with satellite imagery, we can very easily understand and plan our infrastructure. How do we plan our renewable energy sources? Where do our people are? What type of demographics are they? Where do we need to send a certain money for a certain project? So this, in fact, has a lot of, in this way, we can also have a lot of social and economic benefits from this technology.
Thank you so much, Jyotsna, for the conversation today. It's been very interesting, and wish you the best at SpaceSense.
Thank you. Thank you, Alessandro.
Goodbye.